Practice a couple more problems, finding the common denominators, adding the expressions together, and then a short quiz, 3 questions for section 8.4. So let's look at that worksheet. We're going to start at number 7, and then we'll look at 11. 7 and 11, they sound nice together today. Number 7, you have a fraction of 6 over x plus 4, and then it has a minus 3. We actually graphed functions exactly like this in section 8.2. This was the HK form of the rational function, finding the asymptote. So we've graphed this function. Now we're trying to simplify it by subtracting the 2 expressions. And the 3, that minus 3, if you want to, you could really make anything into a fraction. So we could place this over 1, just so that visually you see it as a fraction. So Riley, you have a 1 fraction and a minus 3. What would the least common denominator be? Yeah. So what does the one on the left have? And a plus 4. So that whole part there, x plus 4, that is a factor. Think of that as being grouped together. So x plus 4 is an entire quantity or factor. So my denominator has to have an x plus 4 in it. The other denominator just has a 1. Remember, the least common denominator is a multiple of the denominators. So if you multiply x plus 4 times 1, Riley, does it change x plus 4? No. So the least common denominator is x plus 4. So whatever the one on the left has, that becomes part of your least common denominator. And then if there's a different factor on the right, you want to also add that into your least common denominator or multiply that into your least common denominator. So our least common denominator is just x plus 4. So 6 is already over x plus 4. So that's going to stay as 6 over x plus 4. But the 3 is being divided by 1. And we need to have the x plus 4. So that means we have to take the 3 and multiply it by x plus 4, which makes 3x and then plus 12. Questions on that? So I kept it as a fraction. I found the least common denominator of my 2 fractions. And now you have to subtract. And remember, subtracting is really adding the opposite. So both of those terms must be subtracted. When you do that, you have a 6 and a minus 12. That makes a negative 6. And then we have a negative 3x. So negative 3x and then minus 6. And then I would go one step further and I can see the numerator has a factor of negative 3 in common. I would factor out that negative 3. Questions with number 7. So let's go down and look at number 11. So number 11, we have 3x over x minus 5. Another subtraction problem. So you're subtracting 2 over x squared minus 25. So what do you do first? Ava, what do you think you do first?
Did you multiply the left by x minus 3 and then wait? Oh my gosh, this is
You're looking at the other one. It's all right.
okay. Just kidding. I took x squared minus 25.
That sounds like an awesome thing to do. So factor first. X squared minus 25 factors as x minus 5x plus 5. So perfect square, difference of 2 squares. So you're no longer looking at that as the least common denominator. So your least common denominator, start with the fraction on the left. It has an x minus 5. Add any or multiply that x minus 5 by any additional factors that are on the right. So Ava, what other factor is on the right? Right, x plus 5. So the x minus 5 is already there, but the right also has an x plus 5. So x minus 5 was on the left. Any different factors need to be multiplied to make the least common denominator or the least common multiple. So looking at what we have, I'm going to uncancel this. You currently have a 3x and an x minus 5. But the denominator, the least common denominator, has an x minus 5 times an x plus 5. So we need to take that 3x times x plus 5. And that becomes 3x squared plus 15. The one on the right, it's a 2, and it's over x minus 5x plus 5. Does that 2 in the numerator change? No, because it has the exact least common denominator. So it's just going to stay as a minus 2. So if the denominator is exactly the, if the least common denominator is exactly the same as the denominator in your original fraction, then you're not changing the numerator. So when you subtract, we have 3x squared. You're subtracting 2, so that makes a negative 13. Oh! This to say, Mrs. Kane, you totally forgot the x with the 15 there. And then the minus 2. And our denominator x minus 5 and x plus 5. And then a quick check. Just do a quick little check. Can a negative 6 ever combine to be a 15? No, so it cannot be factored, but make sure you are checking that. So check to see, can you factor the numerator? Questions on number 11. So we're gonna do, I think 2 more. There's like 4 or 5 examples remaining, but I think we'll look at 2 more in the notes. So if you wanna head to the chapter 8 note packet, and I'm gonna look at page 21, and at top of page 21, it says independent practice. I think we'll do 2 and 4, the 2 even problems. Take a look at those 2. The denominators look a little more interesting. And it's nice, one's addition, one's subtraction, so we get a little example of each. So again, this is page 21 in your packet. So Jordan, how would you start by determining like least common denominator? What would the first step be? And how would you factor that?
Take out 2. And then the second fraction, x minus 3.
Excellent. So factor first. To get the least common denominator, we're then going to look at the denominators of our fractions. Start with the left. The left has the number 2. There aren't any other numbers, just the number 2, the coefficient, and then it has an x minus 1. And then look at the right side. What else does the right side have that would be different than the current denominator that we have? An x minus 3. So my least common denominator is the 2, the x minus 1. And then the right also has x minus 3. So any new factor needs to go in your least common denominator. So 2, x minus 1, x minus 3. So now we need to move to the numerator. The numerator says x plus 2. The denominator is 2 over x minus 1. That's our current fraction. But to combine these, we needed the least common denominator to also have the x minus 3. So the numerator is a quantity. We need to multiply that by x minus 3 because that's the part that's in the least common denominator that isn't in our current denominator. So Jaden, when you take x plus 2 times x minus 3, what do you get there?
X squared, that'd be negative 1x. And, minus 6.
Good. So that is our new denominator. We multiplied it by the missing piece, essentially, the part that wasn't there, because that was part of the other denominator. But to have a common denominator, I needed that piece. So now looking at the fraction on the right, we have 2x plus 1. In the denominator is x minus 3 and x minus 1. Grace, what would be different from the least common denominator to the denominator on the right side there? What would be missing? The 2. Yeah, the 2 is the missing part. So we need to take the numerator and multiply it by 2. And then that becomes 4x plus 2. Questions on how to get to that step? So Gabby Snyder, after we get a least common denominator, how do you add them? What are you looking for at the top? Yeah, the like terms. That's the word you were looking for, right? Which ones are like terms? And yeah. And then we have that x squared. So this becomes x squared. Okay. And then down here we have a 2, an x minus 1, and an x plus 1. All right, so before you quit, before you're done, can that numerator, which I think I wrote pretty large, let me shrink it a little bit, move it to, can that numerator be factored? Don't move on to the next problem. Jordan, you're shaking your head. Can it be factored? How can you factor it?
X plus 4.
The denominator is 2, x minus 1, x plus 3. Jordan, what do you notice about the factored numerator?
X minus 7.
Exactly. So this is a case where once you factor the numerator, the fraction can simplify. And if it can be simplified, we want to make sure that it is a simplified fraction. So after you factor it, the parentheses x minus 1 is the same factor. And when you have a factor that's identical in numerator and denominator, it does cancel. So we only have an x plus 4 on the top, and then the 2 and x plus 3. And you can leave every denominator in factored form. Factored form is actually simplified. When things are factored, they're simplified. Questions on that one? So then, yes.
I'm sorry.
No.
How did it? I'm gonna miss it. But did it change to a plus sign?
Did it change to a plus sign?
The x minus 3 or the x plus 3, or it should be it. I don't know.
Where are we at?
So it wasn't x minus 3.
Oh, down here. Yeah.
Okay. I just don't know.
No. No, it's me not being able to write. No, you're good. So why don't you try the last problem? Factor first. So we have a 4x squared. That doesn't factor. 8x squared minus 12x. That one needs to factor. Alyssa, what could you take out of 8x squared minus 12x? A 4. What else do they both have besides a 4? An x, yeah. And then leftover would be
2x minus 3.
So start with the numbers. They both have a 4. The one on the left has a 4, the one on the right has a 4, so that has to be part of the common denominator. Brooke, what else would be part of the common denominator? It is x squared. So when you look at the variables, the single variable by itself, take the larger of the two. And then Brooke, what else? 2x minus 3. So there's an 8 and a 4x squared, but not the 2x minus 3. So that makes 16x minus 24. The other one has a 4x times a 2x minus 3, but it doesn't have an x squared. It just has an x. So x times x would make it x squared. So that would make 2x plus x squared. So again, the 4x8 over 4x squared, missing the 2x minus 3. So that's 16x minus 24. There's a 2 plus an x. We have a 4 and an x and a 2x minus 3, but we don't have the x squared. So we need to multiply 2 plus x times x to give us 2x plus x squared. This is subtraction. Subtraction is really adding the opposite. So make sure you are taking the opposite of that second fraction, the entire numerator. So Faith, when you combine your like terms together, what do you have in the numerator?
No, plus 15. Plus.
So, okay, if you look up here. So there's a negative x squared and then a negative or 14x and then just the negative 24. Just see like what you're multiplying by, what is it missing? Questions? Are there any two factors that we could, or anything we could do with that numerator to help us factor it at all? What could you take out, Brooke? Yeah. I'm gonna take out the negative first. That might help. So if you factor out a negative, that makes it easier when you're looking at a x squared and it's a positive x squared. Way easier to look at. Yeah. And then the 4x squared, 2x minus 3. So in this case, there isn't a factor on the top and bottom that will cancel like the last problem, but every once in a while it does happen. So factor the numerator, make sure it's in factored form, just in case something from that denominator can cancel out. Questions? When you're finding the least common denominator, don't take shortcuts. So have both of those denominators there. Don't take any shortcuts. Make sure you're writing. What are you multiplying by? What is it missing? Try and skip a step. There's little mistakes that can be made. Any questions? All right, so those were just the examples that I kind of wanted to practice through with you. As I said, I have a short 3-question quiz. When you're done with the quiz, there should be some time because it really is just a short 3-question quiz. And this is just on multiplying, simplifying. So when you're done with this quiz, you should have time to start your homework. So for those of you at home, if you want to head to Google Classroom, I'll pull up the quiz for you. All right, so if you're at home, the quiz should be posted. Please let me know if you can't find it. Again, short quiz.